Hello everyone, and welcome to another day of pre-calculus. Fun fact, I just looked at the calendar, and including finals week, we only have 5 weeks left in the school year. What is finals week going to look like, you ask? I have absolutely no idea, but that's only 5 weeks. So I'm just letting you know we are very close to summer, so please hang in there. Today's lesson is going to be on the law of cosines. Now, this does not say law of cosines day 1. This is just law of cosines because we're doing it all in one day. Law of cosines, the equation's a little bit more interesting, but that's the only interesting thing about it. Really, it's just, here's the equation, you plug things in, you make the triangle. There's no special ambiguous cases or anything like that. You just kind of do it to it, which is why we're only going to have 2 examples after I explain what law of cosines is. So hopefully this video will be shorter than the last one. So, law of cosines, we're going to use that in 2 situations. So we're going to be using that whenever we have side, side, side. So whenever I've given you 3 separate sides. If I haven't given you a single angle, only sides, that's when we're going to use law of cosines. We will also be using law of cosines in the situation of side, angle, side. So meaning that you have 2 sides with an angle in between. Now this is very important because this is the same amount of information as the ambiguous case for law of sines. So instead of side, side, angle, this is side, angle, side, which is very different and so different that you even use a different equation. So please make sure before you do any problems, you draw your triangle. Drawing your triangle is very important. On the test next week, I'm going to ask that you draw a triangle for every problem that you need to solve. Now, law of cosines, like I said, the equation is a little bit more interesting. If you want to take a look at your textbook, it gives the derivation of law of cosines or where that comes from. On page, I wrote it down, 556. So if you would like to see where law of cosines comes from, that is on page 556 of your textbook. If you do not have your textbook with you, there is an online version, a PDF version on my Canvas. But law of cosines is going to be this whole shenanigan right here. You got, I forgot, that was still in the pointer. Okay. C squared is equal to A squared plus B squared minus 2AB cosine of your angle C. Now, doesn't that look just like so much information going on? It's a lot, but it's okay because it comes from 2 things that we recognize. So if we look at just this first part here, C squared is equal to A squared plus B squared, I'm like, hey, that's like my Pythagorean theorem. And then the rest of it, you're using the information of 2A, B, C. Now, notice that C is much larger than the A and the B, because that is an uppercase, meaning it is an angle, cosine of an angle. So if you can remember your Pythagorean theorem and then minus 2ABC, you are good. You may also notice, where's my pointer, that whatever side length we have over here on this equal sign, that's also the angle we're going to be using over here. So always make sure that those 2 match up. Now, what if, for instance, we're using side, angle, side, but I didn't give you angle C? What if I gave you angle A instead? Well, what you can do is you can just rewrite law of cosines, but replace all the A's with C's and all the C's with A's. So you can have, I forgot that was still in red. Let's undo that. There we go. You can have A squared is equal to B squared plus C squared minus 2BC cosine of A. Or if you wanted to have B squared out in front, you can have A squared plus C squared minus 2AC cosine of B. So you can use any of these. These are all law of cosines. They are not different equations. They are just variations of the exact same thing, depending on what information you're given, whether you're looking for side length C or side length A, and solving things in this manner. Now on the test, you will be allowed to use the equations. We will have them written on GoFormative. So you will have these here. However, it is going to be a very good idea to have this memorized just for your future math career. So now that we know when to use law of cosines and what law of cosines is, let's do some practicing, shall we? So we're going to do one example of side, side, side. We're going to do one example of side, angle, side. First example is going to be side, side, side. So let's take a look here. I'm going to draw myself a triangle. Actually, we'll do this in black. That'll be good. Is this to scale? I don't know. Okay. So let's see. We'll do A, B, C. We're going to say that side length A is 9. We're going to say that side length B is 6. I'm going to say that side length C is 14. So this is an example of side, side, side. Haven't given you any angles. Now, here's the important thing, probably one of the most important things of this lesson. When you're dealing with side, 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 always solve for the largest angle first. I'm going to write this again in all big red letters because that's going to be important. Always solve for largest angle first. Now you may be like, Miss Twain, how do I know what the largest angle is? You did not draw this to scale, and there are no angles. Well, if you remember from our last couple of videos, the largest side is always across from the largest angle. I'm going to make that note. So the largest side is always across from the largest angle. So if that is true, I can see, hey, 14, that's my largest side, so I'm going to want to solve for angle C first. So that means I'm probably going to want to use the equation, the version that has angle C in it. So we're going to use the C squared is equal to A squared plus B squared minus 2AB cosine of C, because this has angle C in it. So let's take all the information we have and plug it in. So let's see, this is going to be 14 squared is equal to 9 squared plus 6 squared minus 2 times 9 times 6 times cosine of C. Okay, so let's see, 14 squared is 196 is equal to 81 plus 36 minus 2 times 9 times 6, which is 108, times cosine of C. Let's see what can I combine. 81 plus 36 is 117. So 196 is equal to 117 minus 108, 8, cosine of C. Now, a lot of us on instinct are going to go, oh, 117 minus 108, okay, that's 9, go from there. Do not do that. That is bad math. Please don't do that. In our order of operations, no, let's keep that as an arrow. Order of operations says that multiplication comes before subtraction. So the fact that this 108 is being multiplied to this cosine of C is very, very important. I can't subtract these because this over here takes precedent. Also, today's word is chrysanthemum. So if you find me during a Zoom meeting, please say the word chrysanthemum. Anyway, so if I can't do that, what are we going to do? Well, first I'm going to subtract, I don't know why that became a 9 all of a sudden, 117 on both sides, and that is going to give us 79 is equal to negative 108 times cosine of C. And then to get C by itself, I'm going to divide both sides by negative 108. And you know what I'm not going to do? Plug that in a calculator, because I need to keep everything as exact as possible for as long as I can. So this is going to be negative 79 over 108. Maybe that can be reduced. I don't think so, because I think 79 is a prime number. Is equal to cosine of C. To get c by itself, I'm going to use cosine inverse on both sides. And now that I have c by itself, I can plug this into my calculator, and I'm going to end up with c is equal to 137 degrees. C is equal to 137 degrees. So this is what law of cosines looks like. I'm going to take this, draw this, and there we go. So that is the first part of law of cosines, but we still have two other angles to solve for. Now, while this law of cosines in general might be more straightforward, I feel like I've practiced with law of sines a little bit more, and it just feels faster to me. So you can repeat this law of cosine, you can repeat this law of cosine step for each of the angles if you want, but it's gonna be faster to just go and use law of sines for our next largest angle. In that case, that's going to be A, because A, our side A, or 9, is the next largest side. So I'm going to set this up, where's my blue, as sine of 137 over 14. Is equal to sine of A over 9. So this is the information we have. All the stuff in green was our first angle. Blue is going to be our next one. So from here, we're going to cross multiply and have 14 times sine of A is equal to 9 times sine of 137. And then we're going to divide both sides by 14. And to get A by itself, we're going to use sine inverse on both sides. So that we get A is equal to sine inverse of 9 times sine of 137 over 14. And we end up getting that A is 26 degrees. So again, you can go through and use your law of cosines again. However, this is just kind of faster, and that is okay to do. I'm going to try to bring everything into screen. Here we go. So we know that angle A is 26 degrees. And then from here, it's like, well, I already know two of my angles. So I can say that, hey, angle B, my next angle, is going to be 180 minus 137 minus 26. And that's going to say that, hey, angle B is 17 degrees. And we've gone through, and we found our triangle. So whenever you're dealing with anything for law of cosines, be it side, 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 or side, angle, side, you're always going to take three main steps. First step, you're actually going to use that law of cosines. I don't know, sorry, that was my bad. Law of cosines. For your next step, for your next side or angle, you're going to do what we did and use your law of sines, because that's a little bit faster. For step number 3, you're going to use your triangle sum theorem. If you're thinking that you've never learned that, you are wrong. Basically, the triangle sum theorem says that the sum of the angles of a triangle add up to 180. So it's whenever we do the 180 minus angles, that's you using your triangle sum theorem. That's just the official name for it. So that's exactly what we've done here. We used our law of cosines in the green section. We'll find our next part using law of sines. Our last part, we're just going to have one angle left to find, no matter how you've done it. So you're going to use your triangle sum theorem. All right, let's do one more example, and then you can get to the homework. If you don't feel like this has been enough practice, I am posting answer keys to the homework, so please make sure you go take a look at those. All of those are, in fact, on Canvas. So let's try another example. And this next example is everyone's favorite thing, a story problem. Yay! Yeah, there's no way we were going to get through the rest of the year and do absolutely no story problems. Trust me when I say we are doing far fewer story problems than we would if we were at like brick and mortar school, but we want to make sure that you're still doing real life stuff because, you know, We live in the real world. So I'm going to let you know, all I have is a picture and part of an equation. I couldn't find in my notes the original story problem. I think it's like somewhere still at school. So I kind of came up with this on the spot. So feel free to make fun of me for it later, but I am going to write the whole thing out just so you can kind of see what this might look like. And I will also draw a picture because I think that is one of the most difficult parts. So let's take a look. So the story here is about a girl named Agatha. Oh, I can already tell you I'm writing way too big. Let's see, Agatha is hanging out by a lake. Feel free to just take a picture of the story when you're done. Is hanging out by a lake. She is holding onto the lines of two boats. One boat, let's call that boat B, is 260 meters away. And the other boat, let's call this boat C, is 350 meters away. The angle between the two ropes is 132 degrees. How far apart are the boats? So this is what we're looking at. For this problem, just for the practice, we are in fact going to be solving for the whole triangle, but this is what a story problem might look like. So let's draw a picture and see what we have. So let's see, I'm gonna make this smaller because I made that way too big. Okay, so let's see, Agatha's hanging out by a lake. So that's a lake. Agatha. Here is Agatha. She is holding on to two lines of two boats. So let's draw boats. Okay, here are boats. Aren't they beautiful? Let's see, we know she's holding on to two lines. Actually, let's make that one a solid line. A solid line. Okay, so Agatha's holding on to two ropes. One boat, boat B, we'll call this one down here, boat B, is 260 meters away. And the other boat, boat C, actually, you know what, I'll write that over here. This is boat C, is 350 meters away. If you have boats at B and C switch, that's fine, as long as you also keep the appropriate length with them. Then it says the angle between the two ropes is 132 degrees. So it's where Agatha's holding onto the ropes. These two ropes right here, that angle is 132 degrees. Now the question is, how far apart are the boats? So like these boats right here, how far apart are they? Now let's call that, I don't know, since it's across from Agatha, let's call that length A. Just, you know, for fun. Anyway, this is an example of side, angle, side. We have all the information we need to use law of cosines. Now, when I'm deciding which equation to use, I know that I'm solving for angle A. Sorry, we have angle A. Solving for side A, so we're going to want to use the equation that has side A by itself. So I'm going to be using A squared is equal to B squared plus C squared minus 2bc cosine of A. So I'm going to take all this, plug in what I know, and solve. So this will be A squared is equal to, what is B? Let's see. B is going to be cross from angle B. So this is side length B right here. This is going to be side length C right here. So that's going to be, oops, that keeps happening. 350 squared plus 260 squared minus 2 times 350 times 260 times cosine, not of A. We now know what angle A is. We know that that is 132 degrees. So I've taken all of my information, plugged it in, and you'll notice I was able to fill in all of the numbers on one side of my equation, which is kind of nice. This is going to be A squared is equal to a whole lot of numbers. So what is that? 122,500 plus 67,600 minus 2 times 350 times 260, which is 182,000 times cosine of 132. I'm going to keep simplifying. My first two numbers added together there are going to be 190,100 minus the rest of that. And I look to see what else I can simplify over here on this side of the equation, and that is honestly it. Again, because this number here is being multiplied to cosine of 132, that takes precedent over this subtraction. So this is as simplified as I can make that. However, I don't have A by itself. In order to get A by itself, I need to square root this whole entire thing. So I now have A is equal to the square root of shenanigans. And now that A is by itself, I can start plugging things into the calculator. I'm going to plug this into the calculator all in one go. And that is going to give me 558.46. And I'm like, hey, you know what? This is a story problem. We should write a sentence. So our sentence here is going to be the boats are 558.46 meters apart. And so this is an example of what I want for a story problem. Normally for a story problem, I'm not going to ask you to find the angles as well. However, just for practice, let's go for it. And remember, whenever we're solving for law of cosines, we always have three parts. First, we do the law of cosines. We already did that step. Next, we're going to do the law of sines, which goes by pretty quickly. Then we're going to use our triangle sum theorem of 180 minus whatever angles we have, and that takes like a second. So we're not going to have too much left in here. So the rest of this is just for fun. First, let's solve for, which one's, let's solve for angle B. So if we want to solve for angle B, I'm going to do sine of 132 over 558.46 is equal to sine of B over 350. Let me grab my notes. Okay, now we're going to cross multiply and have 558.46 times sine of B is equal to 350 times sine of 132. I'm going to divide both sides by 558.46. So I get sine of B is equal to all of this. And now, in order to get B by itself, I have to use sine inverse. So B is equal to sine inverse of 350 times sine of 132 over 558.46. Now that I have B by itself, I can plug all of this into the calculator and get B is equal to 27.8 degrees. So let's go back, draw that in here. 27.8 degrees. So we've done our law of cosines part in green. We've done our law of sines part in blue. And the last step we're going to do in yellow is our triangle sum theorem. So now we're going to do, hey, angle C. Angle C is going to be 180 minus my angle A minus my angle B. And 180 minus 132 minus 27.8 is going to give us 20.2 degrees. So this last angle up here, oh, there's not a ton of space, 20.2 degrees. So this is an example of doing a full law of cosines problem using side angle side. I know this originated as a story problem, and for a story problem, I do not usually ask you to solve for everything. If this was just a story problem on the test, all I would ask for is the picture and the part in green, since that was what I was asking for. Everything else right now is just extra, just for practice. All right. If you have any questions, come find me on Zoom. Let me know. Your homework should be posted on GoFormative. You have 5 problems there for practice. Enjoy your day.